So in continuation of the videos that we have been doing to solve these numericals, here is question number 4. In this question, they are asking you that what fraction of wax will be above brine. So again, we will apply the same logic. That is, weight in air is equal to the upthrust when the body is floating. So weight in air is the total volume times the density of solid into gravity. And when it is floating, the upthrust that it receives is volume of the body submerged times density of liquid times gravity. So here G and G will get cancelled. So this is the total volume and this is solid. In this particular case, it is wax. So that is 0.95 and this is small b, and here brine, which is 1.1. Now we want this. Okay, so what fraction of it is immersed inside? So we will keep this v over here and this will be 0.95 divided by 1.1. So we get small b as if I shift to decimals, I will get 95 and here this will be 110 into big V. Okay, so this will be 5 into 19 and 5 into 22. This will be 0.86 B. Okay, so you can even say that 86% of the volume will be immersed inside. Okay, so if this is a piece of wax that is floating, this is 86% and this will be 14% that will be above the water. Okay, let's go to the next question. Density of ice is given to you 0.9 gram per centimeter cube, and then density of seawater is 1.1 gram per centimeter cube. Again, the question that they are asking is what portion of ice will remain below the surface of water, similar to what we have done. So again, weight in air will be weight inside water. So this will be total volume times density of solid into G. This will be the volume submerged times density of liquid into G. So this get cancelled. This is density of solid, that is 0.9, and here you have 1.1. So again we need small b, so that is 0.9 divided by 1.1 into big B. So small b we get 9 by 11 into capital B. So therefore we will say that volume submerged is 9 by 11 of the total volume. Okay, so if you have an ice block, this is 9 by 11 part of the volume that is inside, and this will be 2 by 11 that is outside. Again, the same reason why icebergs are dangerous for ships. Okay, next question what we have, there is a piece of wood having a uniform cross section and height as 15. So if you take the cross section area as A and the height is equal to 15 centimeters, that means the volume is A into H. Okay, that is the area of cross section into height. So that will be A into 15 centimeter cube. The information that it gives that this particular piece of wood is floating in water with 10 centimeter of its volume inside. Okay, so what does that mean? If you take this piece of wood, so this whole thing we know is 15 centimeter. Okay, so over here 10 centimeter is inside. So again, weight in air is equal to the buoyant force. So weight in air will be area of cross section into 15 times density of wood into G, and this is area of cross section into 10 because the 10 centimeter part is inside, and density of water is 1 into G. So we can also cancel A. So therefore density of wood we get it as 10 by 15, and this is 5 2s are 5 3s are. So density of wood is equal to 0.67 gram per centimeter cube. Now if you want to express in kg per meter cube, you will have to multiply by 1000. Now the same question, it says that when this piece of wood is immersed in another solution of sinking up to 12 centimeters, where this thing is 15 centimeters, weight in air will be equal to the upthrust. So weight in air is the total volume. Total volume is area of cross section into 15 times density. Density we have got it as 2 by 3 times gravity. And over here, A into 12 into density of liquid into G. Again, A and G we will cancel. So therefore, we have 15 into 2 upon 3, and this is 1 by 12 that will come. So here we have 3 1s are, 3 5s are, 2 1s are, 2 6s are. So density of spirit will be 5 by 6. That gives us the value 0.833 grams per centimeter cube. In question 7, what is given to you? That there is a wooden block that floats two-thirds of its volume submerged. So we have, and this is two-thirds of the whole volume. The whole volume is this. Okay. So again, weight and air will be equal to the buoyant force. That is total into density of solid into G. This is two-thirds of V into 1 into G. Okay. So G and G get cancel. V will get cancelled. So density of wood is 2 by 3. So density we get 0.67 gram per centimeter cube. This is the density of wood. Now the same block, when it is placed in oil, 3/4 of it is submerged inside. So over here, this is 3/4 of the whole volume. Then what will be the density of oil? Again, weight in air is equal to the upthrust, and weight in air is the total volume time density, which we got is 2 by 3, and this is G. So this is 3/4 of the volume time density of oil into G. So this get cancelled 2 by 3, and this is 4 by 3, that is density of oil. Here we get density of oil as 8 by 9, that will be 0.889 gram per centimeter cube. So this is how we get the density of oil. Moving to the next question. Okay, so what is given to us is density of ice, that is 0.92 gram per centimeter cube, density of seawater, which is 1.025 gram per centimeter cube, and there is an iceberg. Okay, so they have given us that this volume is 800 centimeter cube. They want to know what is the total volume. Okay, so we know that this is the total volume and this is this volume that is submerged. So how are they related? The weight in air, which is equal to the buoyant force because it is floating. So this is total volume times density of the ice times gravity. This is the volume submerged times density of liquid times gravity. So this is getting cancelled. And here we have density of ice is 0.90. This is small v, this is 1.025. So what is small v equal to? That is 0.92 over 1.025 into big V. Now if you're shifting decimals, you will get 920 and you get 1025 big V. Okay, now how is this 800? 800 is big V minus small v. So that is big V minus 9201025. Okay, so this will be 1025V 920V upon 1025. So therefore, this is 800 and we get this as 105V and this is 1025. So therefore, V will be 800 into 1025 divided by 105 and this comes 7809.52 centimeter cube. That's the total volume of the ice. Okay, so the final question that we are doing, this is kind of a picture that explains this experiment. So here you see a balloon. So what is given to us, that mass of this empty balloon is equal to 7.15 kilograms. That's the mass of the rubber that the balloon is made up of. This volume is 15 meter cube. 15 meter cube. So therefore, mass of hydrogen, okay, mass is density times volume, and density of hydrogen is given to be 0.09 into 15. Okay, so that answer is, so this is 1.35 kilogram. Okay, so mass of hydrogen plus the mass of balloon will be 7.15 plus 1.35, and that will be equal to 8.5 kilogram. Okay, now here you can see that this person is attaching an equipment. Now this is the equipment that will measure all the reading. So let us say that this equipment has a mass of x kilogram. So therefore the total mass now is equal to 8.5 plus x kilogram. Okay, and the total weight will be 8.5 plus x kilogram force. Okay, now this balloon, which is filled with hydrogen, is displacing air, and therefore the upthrust that the balloon will get will be the volume of the balloon times density of air times gravity, which is 15, and density of air is given to be 1.3 into G. So therefore this gives us, it gives us 19.5 kilogram force is the upthrust. Now since the balloon is floating, the weight in air is equal to the upthrust, and here we have 8.5 plus x is 19.5. So therefore x is 19.5 minus 8.5 and x will be 11 kilogram. So 11 kilogram is the weight of that equipment. Okay, it's an interesting question. Thank you.